Okay, it's me again. I want to basically continue the presentation I started in my previous video lecture on quantum computing and yeah, a bit talking about artificial intelligence also. In the previous lecture, I sort of stopped after 1 hour saying that I have a lot of doubts on sort of quantum computing because I don't see how quantum computing storing different states is any different from the way that computers work nowadays. I put that here in the first paper with some ideas, logic and the quantum computing hype, where I basically said computers currently can implement all kinds of logics, very precise logic with a 2, 3 or more data words, I would call it, and then combine them and in various operations, logical operations. And I don't see where and how this quantum computing paradigm is going to change that kind of logic. The other aspect is current computers actually are quite good also at working with fuzzy logic, and that's where you come into the field of artificial intelligence. There are states clearly that are not precise. I often I quoted that question like we want to know, like, or we have questions like, was Napoleon good or bad for Europe? That's a question you cannot answer, and you can invoke various reasons why you cannot answer it. Because it involves, first this Napoleon was there. It's a historical fact. Applying the categories of good or bad. That might be a categorical mistake, as Gilbert Ryle called it. Maybe this is a question that we can say, well, Napoleon was there, and I said it as a Belgian. I must answer that question as positively, because if the Napoleon Wars wouldn't have been there, then Belgium wouldn't exist. So he left the legal system behind, and of course, but he also tore up Europe in bad wars, going to war with Russia, Prussia, and a lot of misery. But artificial intelligence actually will help in terms of at least gathering data that you might not be aware of, historical facts and other things. You go on the internet. And artificial intelligence, simple chatbot in this case, can help you to sort of, make sense of that question. And so, and that happens with, computers today. So I don't see how quantum computing is gonna change that. I wanted to show something on memory cells. Because I talked a lot about computer architectures in the previous lecture. Well, a lot. I just started actually explaining how a 4-bit processor works. Let me talk about memory cells now a little bit, how they work in computers, and sort of say what they can do and what they can't do. And again, there I think. The quantum computing scientists need to come up with a convincing explanation of how their qubits would work differently. A memory cell is I talked about diodes, silicon with that is doped with boron or with phosphor, and then we have that funny thing that you won't find in a book on physics, quantum physics. I talked about that a lot. Why the current goes only in one direction, then you can combine that as we are doing here in a switch, where you have two n-doped pieces of silicon on a p substrate. And then you have a more complicated setup than a simple diode. you have a source on which you can apply a voltage, and you have a drain, and then you have a gate. And that's a switch. If you put a positive tension on the gate, then probably I drew this a bit wrongly. It will create a zone, a depletion zone, which prevents any current from going from here. Sorry, the pen here. From here to there, the channel will be blocked. Let me clean up my notebook. With the switch on, it's a completely with zero voltage or a negative voltage. We will have a conduction channel. So the depletion zone will still be there, but it will be pushed away, and we do have a current from the source to the drain. So the switch is on. A memory cell basically is a very ingenious thing that adds a floating gate. We have here this thing is an insulator, which is there. It's not a perfect insulator, otherwise we couldn't have a switch. That floating gate actually will have some positive or negative charge depending on whether the switch has been turned on or off. And that's actually the floating gate will keep, that's how a floating gate works as a memory cell. It will have an excess charge or a deficiency in electrons. And that's how the 1 and the 0 get measured, get stored and persistently. So it's very tiny. Said current technologies, nanometer technologies, allow us to have an enormous amount of memory cells, possibly simulating in the future the amount of memory cells we have in our own brain. Does a memory cell work like a memory cell in our brain? No, it doesn't. It works basically based on electric currents. And the memory cells in our brain, they work differently. They're chemical. There's all kinds of neurotransmitters that go up and down, and basic thing is that we probably can simulate the neural network in our brain with these memory cells, these computer memory cells. But there's a lot of other stuff happening in our brain, and that's probably something when you talk about intuition or how an emotion can influence your creativity or the clearness of your thinking. That's probably something we cannot model with these neural networks using computer memory cells. I won't go into detail on that, but I think there's a lot of work there. The interesting thing I want to highlight, and that's something that is under and exploited, quantum computing. They will say, well, we can also store like fuzzy states, superpositions of true and false conditions. Like you could have a simple one. +1 is a true value, right? -1 would be a false value, and then 0 is we don't know. And that would allow us then to work with or develop some kind of fuzzy logic that could possibly imitate our brain. I'm not convinced of that, because we can already do that and simulate that, and it's happening with these AI language models and logical models around fuzzy logic. But the interesting thing is actually, we do that with logic, computer logic. We could bring it down actually to these memory cells, because the funny thing I noted when I wrote about these things is that it's not a matter of purely a 1 or a 0 in this floating gate, excess or deficiency of charge. No, actually, there's 4 levels of voltage, up to 4 levels, maybe more, that they can track. So actually, you could at the level of the memory cell already have like a clear +1. and then we don't know. Maybe we could split it up in 3 levels. We really don't know. 0, or it would rather be probable that the statement is true, or rather be probable that the statement is not true. So then we would have 5 values, starting from -1 to 1, over -0.5 to 0 to +0.5. So this is a possibility where you think like, okay, fine, maybe we're not exploiting the possibilities that memory cells have in modern computer architectures. But I'm very skeptical of that. As said, the level of this kind of funny logic, the level where you would apply it on, would not be like, what's a bit, 1 -1. These are 2 values that make sense. At the level of the bit, I think a binary approach, a 1 or a 0, makes sense. Fuzzy logic, you will apply that to logical propositions or statements or other things, and that's at a much more abstract level, way above this machine level that I'm talking about here. Let me now go a little bit to yeah, I'm presenting this. I first maybe should talk about, when you talk about the internet and artificial intelligence, and we're talking about, I said part of the reason why I'm doing this course is maybe I will have to do a course on digital transformation for this EU Academy, which I helped to set up. There's various aspects. I will really talk about formal programs in a moment. I'm presenting this here. This is sort of at TikTok as a new social medium. It has a huge take up, and there's talk of not only regulating TikTok, but also, for instance, WhatsApp, which is owned by Facebook. TikTok, by the way, is often seen as a Chinese, but it's registered in the Cayman Islands, I think, and I don't actually know. It's not a purely Chinese thing. I think there's American and European ownership of ICT conglomerates there as well. But what I see when I look at these things, like TikTok feeds information, I looked at it and I went on it, and I see that this is the same thing as with any other social media. It is regulated, actually. When you're a teenager, TikTok will profile you. Like I mean, it's the only way they can apply the European regulation on presenting truthful messages, or not promoting hate speech, is that at least they need to profile you according to your age. And so they're doing that, just like Facebook would be doing that. So you can't blame them for not trying to regulate the thing. The thing is often also like, oh wow, and there I'm going back to my notebook, is teenagers spend way too much time staring at their smartphone and being on the social media. There was, in the beginning of this year, this rule, this measure that TikTok took to say, like, okay, we're going to limit minors to 1 hour a day. Of course, that can be overruled, and in a magazine like Time, it was immediately said, like, what was it here? That's not going to do much, because it can be turned off, indeed, by the teenagers themselves, or with the consent of their parents. I've got something like, and there I'm going back to my notebook. When I was a teenager, I'm 54 now, but in the 1980s, when I was a teenager, I was like 15, 16, I played a lot with my Commodore C64. That was the first proper 8-bit computer. 8-bit means it was much more you could handle with a 4-bit computer processor, the one I explained here. That was used in calculators. and so that was it. To have characters, words, you need ASCII characters. You need 8 bits to represent characters. In the Commodore, we had a character generator ROM, which linked ASCII code to a dot matrix representation on your screen, so you could actually read and talk to the computer, I would say, in BASIC, not in machine language. The Commodore had actually an operating system, and I remember that I was sort of oscillating constantly between programming in BASIC, which is a more natural programming language, I would say. It uses words, and machine language. Two were linked, I think, by the peek and poke commands, which people from my age will remember, because it allowed you really to work directly in memory and change a memory value, which sort of you could basically do anything with the Commodore 64. You could it was the first modern computer. It had a lot of extensions. It had at that time only 64 kilobyte of memory, which was very tiny, but you could extend it. You could do what was called bank switching. Add additional memory banks, going up to 200 or more. Well, actually 200 kilobyte was the limit, because you could switch only between 2 banks. You could have like 2 users on the Commodore. And then, of course, the operating system would use its own, RAM space to, execute a program. It was a fascinating thing, and I remember that my parents said, like, what the hell are you doing? Because besides learning programming, of course, we would spend a lot of time on playing games. The big competitor of the Commodore was the Atari game computer. And the ZX Spectrum, which was used for a lot of things. It was fascinating because even in that time, and I'll come back to that, it was also used. You could, use your phone line, attach a modem to the port of your C64, and you could go on what was then called bulletin board systems. That was sort of a precursor to the internet. But yeah, we had news groups there, chat rooms, there were messaging services, and then telnet services, just plain data being exchanged according to, the protocol at the time. Plain data words, 8 bits, 8-bit format. And so all the modern ingredients of what we see now, distributed computing, combined with information being pushed or pulled, it was there. Let me go back to this architecture of the Commodore. I could explain it in very much detail. Here we have, the RAM, the 64K band. Here we have the microprocessor. Yeah. 6510 microprocessor. Later in later models, the 8500 processor. It's not the IBM 8500. It was I don't remember the company anymore. And then you could have all kinds of extensions. As said, with the serial port, you could have the modem to play with buddies, some kind of some game, and connect with them. The video card was fantastic. It had sprites, as they were called, small moving little visual characters that you could move on your screen, and there were separate routines for that. It had a sound system that was very impressive, driven by what was it, the sound interface device, SID chip. The company of these chips was MOS, and part of the reason why the Commodore was fairly cheap was that it produced its own chip via that company. Now I'm saying fairly cheap. This is something also I want to add. We thought that was state of the art. Looking at it now, I looked at the manual. I'm going like, whoa, that was complicated as compared to developing some game or an application now. Just the basic combined with the machine language. And also in terms of pricing, the retail price when it was launched was $595. That I'm talking here about 1985. I think that's when it was launched. That was a huge price. Of course, there was immediately like a price war, and these companies, I think, went bankrupt. The main competitors were, I said, the Atari, and then the ZX Spectrum. That was a computer we also had at home, and they shared basically the same thing. 20 KB ROM with combining BASIC and a kernel with an 8. Apparently there was a spelling mistake, but it stuck. That was the Commodore's machine language operating system. 16-bit addressing. So we had 8-bit data words, but we could do 16-bit addressing. So to indeed address that 64 kilobyte memory, 64 kilobyte. We did amazing things with that. And now, yeah, you know where we are. We are at the terabyte solid state memory in just a home computer. Going back to sort of where it all led to is that the Commodore went sort of developed into more a game computer, and IBM basically and had sort of the genius to first come out with something that was much more powerful. This is the screen of an IBM PC loaded with the operating system, which was then called CPM. That also sort of called BASIC as the programming language, but it was licensed from Microsoft. And Microsoft then developed in the whole thing into an entirely new operating system, which is called MS, a disk operating system. The hardware that came with it, you can immediately see there was it was incredible. We had a hard disk drive. We could still work with the old floppies. The Commodore had a magnetic, had a cassette tape. IBM developed, floppies, floppy disks. And you could have this one here had 3 floppy disks, which could, I don't know, it was in the megabyte range, but the main thing was a hard disk drive of 10 megabyte, and there was room for an extra one, so you had 20 megabytes of a hard disk drive. Input-output times are, of course, slower for hard disk drive. It's not solid state, but that was, 1985, 1990, where, that PC was clearly an entirely different beast and allowed to do totally different things. It also came with what was then the killer applications, spreadsheets, Lotus 1, 2, 3, which ran on the DOS system. It came with database management systems, first hierarchical ones, then relational ones, which developed in these really beautiful products. I'm quoting, it developed into Access 2000. I'm quoting that because I like that. Access 2000 for the first time brought a very intuitive graphical user interface for modeling data, a data model, and also, combined it with what I then called, rapid prototyping, forms. And there was a whole philosophy. People understand forms. You can show them a form to fill in, and they will understand that much better than an abstract entity relationship model. And Oracle Forms, Access, and other relational database management systems, combining, generating a data model even from the forms that you would design very quickly for a user to show like this is what the system is going to do. that was amazing, and that's something you could never do with the with a Commodore architecture. So these bulletin board systems quickly evolved into sort of browsers, I would call them. Netscape came from that, and Netscape made a big push to make all that stuff. A lot of the stuff then was developed already by geeks, and it was open source. We had the open source initiative in 1989, which meant that that had a lot of success, and someone like me, could could indeed share code. Well, share code I didn't develop a lot. I had two brothers who did that. But download it, and yeah, I'm gonna talk later. But it's sort of where the cloud sort of slowly developed. As I said, I'm from 1994 when the Commodore went out of business, and this machine, the IBM PC, was really the thing. We had the manufacturer Compaq, who sort of, instead of a heavy desktop computer, I think the IBM PC was like 15 kg or 10 kg, developed these lightweight portable computers, which still pretty much look like the computers we use today, except that they're smaller, thinner, lighter, etc. The revolution really, but I'm gonna put a bit of a disclaimer on that. Eric Schmidt, as the Google CEO back in 2009, I'm making a bit of a jump now. He created that new paradigm, following on the fact that we're moving away from a mainframe and dumb terminal model for transactional systems to there's a lot of logic that can be implemented, that can be done by the client. And in between we have the browser, and Google's strength is basically, I think, that they got that the browser becomes the computer. And I think the main paradigm shift there was that we were thinking like, we have a user and we have a computer system, but and this is the thing in our modern times, the browser, we talk about object-oriented modeling and all that. One of the objects is you, and the browser, while you're using the system, is going to gather as much information on you as you are probably getting out of the system. It's a totally different type of information, but where you are on a screen. And then indeed what happens in modern times is all kinds of data of, what are you Googling? What kind of applications are you using? And that's the interesting thing, where the internet has become intelligent in a way that it's no longer a passive player, and you sort of see what you want to get out of it, and what kind of application you want to do, what data you want to modify in a system, and you log on to something. The internet is going to gather a lot of data about you, and this is where then in modern application development we talk about, yes, this user journey, and we immediately combine already sort of a design of our system that's going to help us to not only bring you our product or our service in a way that is much nicer for you, but also is going to gather the data that is needed to make it even better, and make it even more useful for you. And that's sort of the thin line between where you think like regulation, should we regulate all that? Yeah, maybe, maybe not. I'm going to show you some things on how I use, first on the difference of Google and Microsoft. Now basically we interact, I think, with the internet and with remote systems in two ways. Either we use our browser, right? And there Google Chrome and Microsoft, they have come together in a sense that both are based on Chromium's open source web browser project. So, and Samsung Internet, Opera, and all that, they also use the same. So that has the same capabilities. The only outlier is Apple. which has about 30% market shares. The second thing that came is the smartphones. So where the concept of an app substitutes for, with a smartphone, you're not going to work through the browser, but directly have an app running for most commoners on your Android operating system, with Apple again being the outlier and having its own operating system. Both are Unix like operating systems, so in that sense also technology has converged and is coming together. So basically it's what is the competition when the architectures are similar, when the capabilities are similar. I'm gonna go maybe to my Gmail. Okay, yeah, why not? If I sort of have a Google account and I have an Outlook account, right? So I'm a customer. I'm using both the whole Microsoft suite of applications. Google is amazing. So we also have, what I love about Microsoft, word processors and Sheets, Excel, well, Google Sheets. We can do PowerPoints. We can do publishing. But it's all through the browser, indeed, that we are working. So Google really can keep track of us, and that's where Google Ads. I've pre-opened it. That's sort of where even on these videos, I'm using YouTube basically because I don't want to transfer a 200 megabyte file, via an email and say, well, look at my PowerPoint presentation. I mean, a PowerPoint presentation with sound and some videos is quickly, a gigabyte or more, or 2 gigabyte. So that's one of the reasons why I use YouTube, why I have a channel. And I started playing a little bit with when you go on my channel here, my videos. I sort of said like, okay, maybe I wanna promote them. You see, so you have this option here, promotion, through Google and YouTube, and it's very interesting. You don't pay a lot, and probably if you're still listening, or you listened, or you were alerted to this video, it's because at 2 points in time I did pay like a few $100, and let me see the overview. Yeah, I have that here. Oops. Where is it here? It's not let me use the screen here to get back to the. Why is it not going to the main statistic? In any case, maybe I shouldn't be showing this under the terms of agreement. But at 2 points over the past year, so I started doing these videos since 1 or 2 years. I did pay like a few hundred euro to promote my videos. 3 times I did it very briefly. I think. Yeah, end of August also, and it's amazing. You get 100 and more than 100,000 views, where otherwise you get only like 20 or 30 or 40. These boosts have brought me almost 2 million impressions. That's when it appears on your screen, and out of that, 73,000 proper views. A view is defined as someone who watches your video longer than 30 seconds. Most people will swap or skip an ad after 10 seconds or less. So apparently this is not so bad. Maybe my voice is kind of nice and people like to listen a bit longer. Or this is the other thing, I didn't do that, conversions. You can do a campaign, and it's really amazing. I was sort of, when I saw these tools, I was thinking about my marketing course 30 years ago when I was studying in economics. It is amazing, these conversions, make people pick up a phone and call a number, or visit your company website, or order something. Of course, the ultimate goal, and then you have campaigns that optimize that. And so my thing was just push the video a little bit. And so my conversion rate apparently was was apparently for media, social media advertising, not so bad, 4%, and I paid 1 cent per view. I stopped that because this is the other thing maybe I want to show. You wonder, like, I wanted to get interaction and comments, and so I have a breakdown of the people for age here in Insight. But what I also saw is that if I look at that, consumer spotlight under 10. Yeah, most of about 40% of the clicks on my videos in these campaigns are hardcore gamers. So indeed, people who are addicted to the screen and just want to relax a little bit, I guess, and listen to a voice like mine. So I stopped doing that because, of course, that's not my public. When I talk about, quantum mechanics or these kind of things, I will close that because actually, that sort of information probably that you shouldn't see. But I'm using Google. I must say I'm very positively impressed by when you do want to use basically what is social media marketing to promote a video or whatever product or service you have to offer. Google checks where you live. You need to send an identity document, a passport or an ID document. The credit card is being checked, and all these kind of things. So it's not like you can be someone that is not known, some kind of dark force, or just some kind of bot. Google checks your credentials before you start pushing, before you can push a video into the feed of other people. So that's Google. It is amazing. It's all web-based, and the thing I do gonna note is that Google collects an awful lot of information about you. Everything is on the cloud, and that's where sometimes I'm going like, yeah, maybe some regulation is needed because I said Google is a company. When I look at how things go and how I said they check what you do, you get feedback. The video when you upload one, it gets screened for language and appropriate language and all these kind of things. So it's very professional. At the same time, it does make it very easy for Google then to sort of manipulate and use that information. One thing we discussed. I'm a member of an association that works on cold fusion, and probably I want to show this, is that oh no, I don't have that. That's GitHub. At one point in time, we were surprised to saw that in cold fusion. I don't have it. You can look it up. But that Google has has taken some patents on very technologies that haven't matured yet, but that are related to this innovative field of cold fusion. I'm a believer in cold fusion. I don't think we can get net. And then we were going like, how the hell is Google? Some people felt that they've like preempted. Research that is ongoing by already taking a patent on it. Let me maybe Google it because it was in the news also. Patents, cold fusion, Google. Google patents, yeah, here. I'm wondering, like, what the hell? Google has nothing to do with this. This was a patent that was taken, well, apparently a long time ago, but there have been more recent ones. And I'm thinking, like, it's interesting, but I was thinking, like, is Google really maybe picking up very promising things and then sort of preempting the research groups from patenting this thing themselves by taking a patent themselves. It's still not an allegation. I hope this doesn't get screened out in my presentation. Of course, Google has the right to do that, to work together. I'm sure it's all in good faith that they are working with other research groups that I'm not aware of, and that they patent and in this way contribute to science. But I was thinking when I saw this is that actually Google could do that. I'm not saying they're doing that, but they could actually screen and what is happening, because all your documents, all your research documents, even in preprint stage before it has appeared in a journal, it's somewhere there. It's in the cloud, and so there you have an issue of privacy, I think, and that's where I prefer Microsoft, like Word, Excel. It runs on my computer as an application. I store the data locally, and I feel much more at ease with that rather than having all of my data in the cloud. Now the thing is, Edge, as said, runs on the same platform, and how I want to show this is when I now click on Outlook, I used to be a heavy Google. I only used Google Chrome. Outlook now, when I it's not loading here. Okay. I don't know what my computer is doing. Yeah, it's loading. So Outlook now, whenever there's a link, I can no longer select Google Chrome is still my preferred browser on the laptop. But when I use Outlook and I go on, for instance, there's GitHub and it has a link, this thing. Well, these are things you shouldn't see. There's a problem launching the new Outlook. I don't know why. I just installed it this morning again because the new Outlook on Windows 11 is actually more browser based than really on your computer in terms of storing emails. But so Google and Microsoft are coming together in sort of Windows 11. They're still competitors, but the way Windows 11 works, I would say, is more like Google. Like the browser has become a bit more of the computer than in the past. Maybe to go further on, Windows PowerShell, for instance, is this is the successor to the MS-DOS prompt. It looks the same, but it's a completely different thing. It's it gives me a keyboard. I don't know why. This is the new PowerShell. I don't know why it gives me a keyboard. Because probably it senses that I have a touch screen. The Windows PowerShell is going to allow you to, I did that on another computer, is really to, work with a Linux virtual machine on your computer. You install one. Ubuntu here is not working because I have installed a virtual machine. But then this is what I want to tell you. I did microservices on... installed the IBM Docker platform, Kubernetes, a whole development environment with a packaging manner, Helm, and then continuous deployment tool, version control system with Argo, all these kind of things just on your laptop. And it was actually, I'm showing this also. This guy is amazing. Platform engineering on Kubernetes. He took me. I mean, his book took me through. How microservices and continuous deployment, continuous integration really works in like 3 or 4 weeks. But at the same time, I had this funny experience where he wrote this book for developers who work in a very structured development environment with access to Linux machines basically, and I sort of had to start from scratch and say like, okay, I'm gonna put this on a Windows machine, and so I was apparently the first one who we had a little exchange on that because I ran into a few problems which were quickly solved, and he congratulated me with that, and I said like, well, it was all thanks to the amazing capabilities of the Windows PowerShell, and then yeah, Microsoft packaging managers, I would say, or who are based on it, like Chocolate. So an amazing experience of combining, this proprietary software, the Microsoft environment, with open source tools that you can download from GitHub, or other. I'm rambling a bit, I think, and so I'm gonna, probably conclude. I said the objective of this thing was, maybe to prepare for, some kind of presentation on, digital transformation. How has it transformed the way we are working with computers now, the way we are accessing, the community, early on 30 years ago, through basic things like bulletin board services that indeed had news groups and on science and stuff. And how has that changed? In a way, my conclusion is not very much in terms of architecture, but of course, I cannot compare the way we worked 30 years ago to the amazing possibilities and the ease of working with computers now, be it based on proprietary environment Google or Microsoft, and then sort of the open source movement, how it has developed. I wrote a note here. Yeah, Chromium. This is the amazing thing, yeah. Okay, Chromium is sort of then the engine of the browser. Which languages is it written? It says a lot. C++ is most of the code. Of course, the rest is then HTML5 or HTML. XML, the sort of hypertext markup language that generates a web page, and then JavaScript as a scripting language. I'm a bit surprised not to see PHP, but PHP doesn't have that capability of cookies and calling routines from the server. So that's probably the reason why PHP is it's more like a passive scripting language, if I may say. And then some Java, C, Python. Python is a really nice language to work with it. I enjoyed it a lot. I redid my certification in it. Well, I redid it. I never had one, but I did one. I knew Python. I worked with MathPy and SciPy, and the amazing thing is nonlinear regression. We could have only dreamt of doing nonlinear regression. We were when we were doing research 20, 30 years ago, building a model. It was linear regression, and when you wanted to do nonlinear regression, well, you would do a transformation of your variables. You would take logarithms of them, or apply some polynomial function to it. Very complicated business. I could show it. Python, you can do a non-linear regression. You can fit a polynomial, a function, a square, a cube, power 4, any nth order polynomial you can fit to your data. Amazing, just plain amazing. So I think I'm a technology optimist. Technology is enhancing human intelligence in ways that could not be foreseen. I think I said on artificial intelligence, there was a boom of it in the 90s as well. It sort of broke down because I think we wanted to go too fast. We wanted immediately to sort of work on what was called generic or general artificial intelligence, really mimicking, this is the Turing test. Can you talk to a computer and will it, give you answers that without you sort of feeling like, oh, this is not a computer, this is like a human being I'm speaking to. So that sort of machines didn't work very well then. It does now, with ChatGPT and these chatbots. It's really the Turing test. All these machines pass it easily. But yeah, machine learning is something different. Applying artificial intelligence to analyze all that data that comes when billions of people use a browser. Segmenting, profiling becomes possible. Artificial intelligence, apparently, I hear from a colleague, is really good in writing code or debugging code. Java code or C++ code or whatever code, is quick at it. So yeah, it risks putting the menial jobs, I would say, in the programming business, to make them meaningless. I think developers nowadays have to be multi-stack, have to use these tools to generate code quickly. It's hugely promising in terms of dealing with legacy software. The old COBOL code that is still running on mainframes and all that stuff, to rewrite it. What is making a comeback is low code. One of my first jobs was computer-aided software engineering with James Martin Associates, where indeed you would use a really high level. It was called a fourth generation programming language at the time. But that term got out of use because now we're probably talking 13 or 16 generation. I mean, languages, we don't talk about them in terms of generations. We talk about procedural language and object-oriented and other paradigms. But the case tools made a comeback, I would say, with the low code. A really high-level language. You develop your data model, and bang, the low code, be it Mendix or OutSystems, will build you what is now called, we called it the rapid prototyping at the time. Now they call it the minimum viable product in terms of a system. And then you can replace it. Rather, you can replace legacy systems probably much easier than 5 or 10 years ago. So the sky is the limit. I'm very excited to go back to the theme of the presentation I started with. Quantum computing is not is not coming with a new paradigm in my view. Artificial intelligence is. That's new. It's been there, the way we use the browser since 2009, 2010, over the past 15 years. The way, we work with big data. That's AI, that's artificial intelligence. So that is probably something in which I want to look at more. But so as for now, I really wanted to just make you feel a little bit excited about this brave new world that we are living in, and the sky is the limit. It's amazing that silicon semiconductor technology brought us to where we are, where we are living in a bit of a brave new world. So that will be it. I will stop. I will upload this and probably, if needed, present it to a few colleagues or friends, and then ask them what they liked about this. As said, for me, the objective is a bit sharing my enthusiasm, and when we talk about digital transformation, to sort of talk freely, base my notebook, and then see what sticks, what doesn't stick with the audience I might possibly have when I might be on a project where they ask me to contribute to some kind of curriculum development on digital transformation on this EU Academy platform, which I helped to bring online about 2 years ago. As part of a wonderful consortium and really the most amazing colleagues. So that's it, and I will stop and